So today we're going to talk about graphing polynomials. You might think that this is kind of pointless because you have a graphing calculator. So why would you ever need to do this without a graphing calculator? But it's useful to know what's going on with your polynomials graphically in case your numbers are very, very large and you don't need to change your window and play around with that and waste time. So that's why we teach you this, how to graph a polynomial, or at least how to figure out what it kind of looks like without your graphing calculator today. So let's get started. So the goal today, predict what a polynomial will look like graphically, including its end behavior. So find the difference in the following. We have y equals x squared. We have y equals negative x squared. So look at these two graphs. You'll notice that this one opens up, we've talked about that in class, and that the second one opens downward, and I know we've talked a little bit about that in class too. Let's look at the equations. X squared, negative x squared. So let's answer the question over here. How do the functions end? Well, if we look at this one, it ends up in the positive direction. And if we look at this function right here, it ends going downward, which is in the negative direction. Let me point this out to you. Positive 1x squared ends up. Negative 1x squared ends down. So let's talk about that a little bit here in this next little part. End behavior is always determined by the blank of a polynomial. So this is always determined by the number in front of the term with the highest exponent. And you may have forgotten what that's called. We learned it in Algebra 1. It's called the leading coefficient. There we go. Leading coefficient of the polynomial. If the leading coefficient is positive, the right end of the polynomial will go in the positive direction. See, we try to keep it nice and simple for you guys. If it's positive, it goes in the positive direction. So you could probably guess that if the leading coefficient of the polynomial is negative, it's going to go into the negative direction. Okay, so it's called end behavior. So let's go ahead and apply that to a couple of problems here. So for number one, y equals negative 2x plus 3. We need to predict the end behavior. Okay, so in number one, highest exponent is going to be here to 1. And we look at the number in the front because that's called the leading coefficient. And that leading coefficient there is negative. So this is going to end down, or you can say that it's going in the negative direction. All right, let's look at number 2. You may not have seen this weird form before. It's kind of like not done for you. So if you feel more comfortable, you can go ahead and you can distribute like this. And you can clean it all up. So y equals 4x minus 42. Again, there is the term with the highest exponent, which is a 1 again, and the leading coefficient here is 4, which is positive, so it ends going up in the positive direction. All right, let's skip over to number 4. Number 3 I would like you to do. You do this one. And number 4, y equals negative 4.56 x to the 8th plus 21 x to the 9th. What's this one? Now, if you just said negative, that's going to end going down. You just got it wrong. If you find the term with the highest exponent, it is right here. And that has a positive 21 in the front. It's not written in descending order like it usually is. So this leading coefficient here is positive 21. So it ends going up in the positive direction. Okay, let's keep on going here. What do all the polynomials have in common in reference to? It looks like down here it says their exponents and their end behavior. Okay, so let's check this polynomial out. Okay, it's pretty long, looks a little complicated, but you know, you're in Algebra 2 trig now, so you can handle it. This one looks real simple. We've seen that in Algebra 1. This one's a little rough, but it's a little shorter, so you probably think it's an easier polynomial, even though it's the same as this one. It's kind of not as difficult. But what are you noticing here about their exponents, okay? Let's look at the highest exponent. So the highest exponent is what's going to be important here. And the highest exponent on this one is 4. And the highest exponent on this one, well, you only got one choice there. It's 2. And the highest exponent on this one is a 4. So 4, 2, and 4 are all even. Okay, so their highest exponents are all even. These are called even functions. Let's talk about their end behavior. This goes up, this goes upward, and this goes upward, and I probably did a bad job as a teacher here because sometimes they go downward also. But what I want you to look at is how both of the ends look. Okay, how are both of these ends ending? That sounded weird, but how are both of these ends ending? They're both ending upward, right? So they end in the same direction. End in same direction. Now, I was a bad teacher here, and all of them end going in the positive direction. So what I'm going to do is I'm going to draw another one. I'm just going to let you see this. So I could have something that looks like this. Looks real crazy, right? But they both end in the same direction, which would mean that their highest exponent then is even. Their highest exponent is going to be even. So let's keep moving. Let's see what happens on this next part. Now, we just did evens. You guys are pretty smart, right? So you know we're probably going to do some odds here. What about these polynomials? What do you notice? Okay, x to the third, x to the, don't you dare say 0, because that's weird. It's to the first. If nothing's there, that's a 1. And x to the fifth. So hopefully here you see that the highest exponent is an odd. Highest exponent is odd. Okay, and let's talk about their end behavior. All right, so end behavior, and we're going to talk about both of the ends of the function. Okay, so the end behavior here, this is downward, it's going up, that's up, it's going down, it's going up. Do you notice something here? With the evens, they went in the same direction. With the odds, they go in opposite directions. Okay, opposite directions. It's called an odd function. Talk about it a little bit more in pre-calc, which I know all of you are looking forward to. So we had even and we have odd functions, and now we know what their end behavior looks like. All right, so let's keep going. Moving right along. The highest exponent of a function is equivalent to how many blank it will have. Solutions. How many solutions it will have. Okay. As we learned in the previous chapter, how many solutions we have is what our x-intercepts will be. Well, sometimes, okay? So not always. I know a lot of you thought that when we did our factoring chapter, but it's not always true. And let's find out why. I mean, I could tell you, but let's actually dig into an example and see why. So in y equals x to the third minus x squared plus 1x minus 1, we should have how many solutions? Okay, so pause for a moment here. The highest exponent is how many solutions you should have. So going back and looking at this function right here, the highest exponent is 3. So we should have 3 solutions. Okay. However, let's look at the graph. So check this graph out. It looks a little weird, like you threw spaghetti on the wall, but how many times does it go through the x-axis? Because I'm sure counting 1. And please don't say 2 and say the y-axis. No. I said x-axis, okay? So how many times does it go through the x-axis? And I only see 1 here. So it says, what's happening here? How many x-intercepts do we have? We have 1 x-intercept. Okay, so upon further inspection, we see that our function will factor to the following. Now look at that there. They factored it for you. I know you're probably kind of upset. You like to factor on your own. You don't like it when people factor for you, but we went ahead, we did it for you. Let's go ahead and see what the zeros are, the solutions are. We know to use ZPP. So we take x squared plus 1, and we set it equal to 0. And we take x minus 1, and we set it equal to 0. Subtract 1 from both sides. And to undo a square, we take the square root. And we never, ever, ever, ever forget to do plus or minus when we take the square root to undo a square. So we have plus or minus, and we know the square root of -1 is a beautiful I, an imaginary number. Over here, we're going to add 1 to both sides, and we get x equals 1. Well, we know x equals 1 is an x-intercept, like we have it right here. But look at this. Yeah, imaginary number, right? So we're not going to plot that on our x-axis. But you'll see positive I, negative I, and positive 1 are all solutions, right? So we have 3 solutions, but the only solutions that we're graphing here are the real solutions, okay? So don't worry about the imaginaries here. We're just going to graph the real solutions, but I wanted to show you, you will have the same amount of solutions as you do the highest exponent. They just won't always all be real, okay? So let's move it down here. Conclusion, even though the highest exponent of a function is the number of solutions, it does not mean that this will be the number of real solutions. I don't know why I'm writing in red, but I guess I'm writing in red now. On the contrary, some functions may have imaginary or complex solutions, okay? All right. So now that we have that, let's keep on moving. Let's sketch some polynomials. I think that was our point today, right? Sketching some polynomials without our calculators. You can handle this. So the first thing you want to do on number 1, let's talk about end behavior. I see a positive 1 in the front here. He doesn't like to show himself, but he's right there. So this will end positively. And we have some ZPP zeros here, right? Hopefully I don't have to show you the ZPP, but the x plus 2, when you use ZPP, x will equal -2. And the x minus 3 with ZPP is going to equal a positive 3. And the x plus 1 with ZPP will equal -1. So I'm kind of lazy, so I go back here and I just plot my zeros, just like that. I know that I'm going to end on a positive like that, right? End behavior is positive. And I'm going to go through these zeros now, and I don't care how wavy you make it, it's a sketch. There we go. Now just look at this graph right here. Without even distributing this out, one end goes up, one end goes down. What kind of function is it, odd or even? It's got to be odd, right? By the way, at this time, I just want to let you know that I'm drinking Gloria Jean hazelnut coffee. And if you're listening to this video right now, I would like you to write down on your notes, Gloria Jean hazelnut coffee. When I come around tomorrow, I'll be looking for that on your papers, because some of you guys like to watch the screen, but you don't actually like to listen to the notes. So I'm going to be trying to catch you tomorrow. And don't tell your friends I said this. If you did it, good. Get the points and let them suffer for not listening to the video. Okay, on this next one here, it's not factored for us, but we're adults. We can handle this. So let's go ahead and take out the -1 to begin with. And then what multiplies to give us -4, but adds to give us -3. And that would be -4 and 1. And since a equals 1 here, we can jump right to the parentheses. So x minus 4, x plus 1. And then using ZPP, we know x is 4, and we know x is -1. So 1, 2, 3, 4, pop a dot, -1, pop a dot. This is going to end downward, like that. So go through, even or odd function, what do you say? Has to be even. They're going in the same direction, okay? Which makes sense, because our highest exponent to 2, right? Number 3, we're going to talk about with your calculator, okay? So pulling this up, let's go ahead and go to y equals, hit clear. And we've got x plus 5, and we have quantity squared. We're going to graph it, we're going to check it out, and it looks like that. So looks like it's touching at -5. Okay, so 1, 2, 3, 4, 5, -5. And this is a 1, so it does end upward. Now, why does it bounce here and yet these two go through? Why does that bounce yet these two go through? And it's because of the square. Whenever we have a square, we're going to have a bounce, okay? It's kind of weird. You might forget it later on, but I'm telling you right now, you're going to bounce if you have a square. So it says what happened to number 3. If it's squared, it bounces. All right, we're going to talk about this last one in class. Okay, so go ahead and leave that one blank, and we will talk to you about it when we get there. And I hope you have a wonderful night and you thoroughly enjoyed graphing polynomials.